Internet of Things, automation, smart grid, healthcare informatics, computer vision, AI, and trusted AI. His research and professional interests are research on explainable AI, trusted AI, deep learning, optimization, Internet of Things, and computer vision. He acted as a keynote speaker in top AI teams. With this brief introduction, I welcome you, sir, for this session. We are very glad to have you on today's session, sir.
Thank you. Thank you very much. Thanks for the kind introduction. So can you confirm you can see my screen as well as you can hear me? I can put
We
on
can
mute
hear
this
you, sir,
one.
and screen is also visible, sir. But it is in PPT mode, sir.
Sorry, come
So
again.
it's presentation mode, sir. We are
Yeah,
not
yeah.
getting.
I'm putting it into the presentation mode. I just started the video, but we don't require that. So good morning, everyone. One sec. Yeah. I'm putting it into the screen share mode. So you can see my screen, right?
Yes, sir. Screen is
Yeah,
visible, sir.
great. So in between also, because we are connecting remotely, so if at all any issues are there, please alert me. Okay, maybe network issues or any screen sharing issues kind of a thing. Okay,
Okay, sir. We'll
so
inform you, sir.
sure. So do I
So
have
one,
time till 11:30 or 12? So
well, sir.
12. Okay, great. So we are effectively 2 hours, and at least what I can promise you is working in this similar area of AI, machine learning, especially on the computer vision as well as the FDP theme, presently machine learning and image processing thing, right? So at least I can promise you, you may be experts in some of the fields, but or you may be entering the fields. I'm sure the faculty may be in a different level of acquiring this knowledge. So by giving the perspective from industry, so at least what I can promise you is you will have a takeaway either in terms of new research problems or at least in the implementation point of it. I hope we can trigger the success of the program. What I say at the end of 2 hours is if I am able to excite some of you on, yes, these look like interesting problems and what industry is looking for, and this, what are the real challenges, even though we talk about a lot of developments in last few years, why still people are struggling to really implement what we are proposing, what we are seeing, right? So we talk about even the successful stories at the same time where the real challenges are. So that's what I bring in last 10 years of working in this specific field. So what I can I keep on referring to some of my blogs as well. So in the interest of time, maybe this topic is almost like a semester level computer vision, and its application is a semester level course kind of a thing, right? Even in Indian or foreign universities. So with that small introduction of the topic, so let me directly jump into the agenda. I keep checking the chart, so even though it's maybe I can keep it open as well. If at all you have any questions or if I need, and this deck already shared with you, so with you in the sense with the program office, so the organizers can you can get it from the organizers, so don't worry on the content, noting the content point of it, but if you can focus on what it is, this just maybe 20-25 slides just to refer us as a structured way of following. But at the same time, if you want me to deep dive or drill any of a specific topic, I can take the help of internet or maybe my own blogs to share you more details. Okay. So I keep asking in between as well, if you're able to follow me, is the pace okay and all. But if you respond, that will be easy for us. Only difference is I can't see you in person or facial expressions. So that's also an interesting problem in computer vision to do it, right? So they are talking about people even in the virtual mode. If you switch on the video, how much you are concentrating on the thing. There are softwares which can analyze and give us. Okay, but right now, because we are in the remote setup, let's see. I'll try to be maybe giving in not in the too much pace wise. I'll keep it moderate, so not too fast. But at the same time, it varies from batch to batch, right? So your feedback in between also will help us effectively. What I feel satisfied is by interacting, and the two out of 2 hours is not like one way flow of 2 hours I'm going to talk. Maybe I can talk around 1 to 1.5 hours, then we can keep, or some of you may be working on interesting research, so we can have an interactive thing, so that way at the end we have some learning for each of you. Okay, with that promise, let me share the agenda with you on we'll start very basic with what is computer vision, then how do you recap basic technique, because if you ask me what are the prerequisites to get full out of this particular session is basics of machine learning or deep learning and some basics of image processing. I'm expecting you, and I checked the program organizers, so they mentioned more or less you are, even though you are coming from computer science or ECE different backgrounds, at least the basic knowledge you have. But if I'm over assuming anything while talking in the specific particular topic, so you can alert me so that I can give some background as well. So the key, once the agenda is set after recapping the techniques, then the one main contribution is what are the top industry applications of the computer vision. So I'll take maybe I prepared a table of different industries, right? So whether you call it as telecom, then manufacturing or retail. So you may wonder why you need to worry being a faculty, what industry you are talking about, right? So yes, there are two purposes. If you see the government of India initiatives these days as well, so they are encouraging more of applied research, right? So even though you may be working as a pure research oriented or a PhD or a maybe research kind of a thing, if you tie to the specific application or maybe an industry, then you will get, it is maybe easy for you to get the support, or it is easy for you to go to an implementation level, then applied research. That itself even will be helpful for the students who are working with you as well. Okay, so that's a broad level view I talk about. That's the first takeaway, maybe for first half an hour. Then I don't want to leave it at the 10,000 feet level. Okay, these are the application names and all that. But if I go little more details of it, so I'm trying to cover, let's say, medical imaging thing, or maybe explainable deep learning. Okay, you may be knowing already what is machine learning, deep learning, how things are working. So they are not any more black box models, especially I'm talking on the backdrop of computer vision, let's say image or videos, the kind of a thing, right? So how do you really understand what's happening inside? And then I'll try to answer why part of it as well. So it's not just only what are the techniques. Some of the techniques, what does that means you can just Google, you will get it. But my way of dealing that particular thing is I'll try to emphasize on the why that is important, right? So why we are doing it, these things. If you question yourself those in a day-to-day activity, you can trigger that innovation mindset, not only for you and even for the students at large. Then we talk about synthetic image generation with maybe some latest technologies on GANs. So GANs is generative adversarial networks. Maybe at that time I'll just check if some of you already working on it, or if it is completely new, I'll give a background as well. Then I'll take about some examples of autonomous driving, maybe a bigger example or a simple example, one or two simple examples in little more detail. Then at the end, we'll try to summarize the challenges and next steps, so that even if you want to build a pipeline as part of your research, so taking out right from interesting problem and then having the data, then how do you go about that? And some of you may question, okay, I have interesting problem, but where do I get data? So I'll handle both the things, and I'll give you some references on that, so that should be able to helpful for you. So this is what I have in my mind for the next 2 hours, or maybe close to 1.5 hours from my side, and then maybe we'll take it some questions as well. So any questions so far? Are we good? Any other expectations from the session? Also, if you let me know in advance, then I can try to do the justice.
So no
Okay.
queries, sir.
Okay. So maybe is there any chart? When I'll keep checking once in a while. You should not disturb the flow at the same time. Somewhere it is there chart. Yeah. Computer vision as is part of artificial intelligence. Yeah, I'll say Nitya, it's artificial intelligence is a set of techniques. So computer vision is a separate field. So if you ask me, computer vision, can it exist without artificial intelligence? Yes. So one way of solving the computer vision problems is using AI. I think that will be clear for you after I talk about slide number 5. Right, it is on the way. Okay, great. So can you share a few concepts on algorithms to handle geo-satellite data in GPS? Yeah, I can talk about that. So I have some information on how do you handle that as well, but I'll talk about that. Okay. Great. So instead of just keeping all questions towards the end, even if I miss something or if I overpromise something and all, it's just alert me towards the end. But let me go with the flow and keep checking how you are able to digest. Then even if I don't cover, let's say 1 2 slides, doesn't matter, right? But at least whatever I covered, it should be clear for you and it should be a purpose so that you can reuse that. Then only the success of this program, these kind of programs will be happening. Okay, great. So if I go back to my regular flow, okay. So how we are defining the computer vision as the name indicates, right? So I'll take some, uh, I could have put the reference here. So usually anyway, I put the reference towards the end where I got this kind of interpretation, right? Each of the, there are some two standards textbooks as well. I hope I added it. Otherwise also I will anyway ping you in the link, right? Especially from the computer vision point of it. But don't worry on the textbook point of it. But when we are talking about here, there are a lot of interesting research, especially from Stanford or even MIT and some of the best places in the world. The first statement what I usually give in computer vision, with the due respect to the Professor Fifi Lee from Stanford University, what she says is, even if you see here, right? So we know that as the name indicates, it has computer and vision. Yes, vision is there for each of us, and then you can see the sensing device aspect point of it. It is either our eyes, okay, and maybe some kind of a webcam or maybe a CCTV or even a drone kind of. It's kind of a camera, right? It's a digital one and it is a human eye. So if you see here, the main point is if I see an image, okay, and my computer, sorry, let's talk about the human thing first. If I see an image or if I show you this particular image itself, what you are seeing me now, your eyes are focusing on that, but this particular thing and trying to understand. So if you see, even though the eye is the starting point, if you see that what is there here and all, actual processing is happening in the brain, right? That's where we are able to interpret. Suppose if I show you this image, maybe you are thinking it's a park, or maybe you are thinking about there are trees, then there are flowers, there is a small bridge. Okay, so those are the things which are coming to your mind. But so what I want to indicate here is the sensing device is eyes for us. Okay, without eyes, we say that the vision is blind, right? But still, the people, okay, some differently abled people, even if they don't have vision, they can process. Maybe they will take the help of other sense organs, and then still they can interpret and then able to feel that, right, in the mind. So the main thing I'm talking there is, one is a sensing device. We may sometimes we may think that okay, eyes are doing everything, but eye is just helping us as a sensing device, but most of the processing is happening in the brain. The same analogy if you see here in the computer vision point of it, the starting with point is kind of a having a image or a video kind of a camera, right? That camera can be any form, whatever you are seeing in the real world, and actual interpretation may happen sometimes even on the edge side, or most, or maybe in the cloud. That I will talk towards the end, right? Initially the cameras are very dumb, just capture the camera. There is a wire or wireless camera, depending on how it is connected to the server or maybe the cloud. Everything is processing and interpreting device in the cloud or the server. But these days, even in the deep learning case, we are talking about some kind of interpretation can be done, some kind of a deployment of models can be done, because these cameras also can have a chip, right? So those are the latest advances which I talk towards the end. But the end, towards the beginning, once we have an image, just like we are processing it, there is an end-to-end life cycle from how you process this image and then take the interpretation. That interpretation can be of a different problems. I'll talk about that. So as one of you are asking, I think Nitya, yeah, as you are asking, the computer vision is related to, if you see here, you are talking about some people of coming from digital image processing background, some of signal processing kind of a background. So there, this part of a portion may be coming from the physics, electronics kind of a thing, and this kind of a portion is coming from computers. So it's more like an interdisciplinary field, which is bridging the gap between pixels and meaning. What does that mean is, whether you have a video, whether you have a image, the basic building block there is a pixel, right? So I hope most of you agree to me. How we are really processing it, the pixels may be converted to some kind of vectors, and that's what actually those vectors, what real system, right? What real system in the sense, what real machine can understand, right? That's I will elaborate a little bit on that. But what main purpose of this is one line. Okay, this maybe I'm trying to oversimplify. I'm not giving a bookish definitions, but I'm trying to help you out in terms of what you can really see the role of computer vision is playing. It has a intersection with image processing, and then that means computer vision, if you see some courses, there will be completely traditional image processing kind of a thing, some filters, some SIFT algorithms, or some kind of non-linear linear filters, then motion detection, how do you see the depth perception, these are all the things. But what I'm concentrating here based on the theme, ML based kind of a thing, right? So the latest advances in ML or DL, machine learning or deep learning kind of activities, those are the things which I am focusing right now. Okay, so it has relation to all these different fields, right? So some one may not be expert in all of them, not to worry. So see where your background is coming from and what kind of problems you can solve is the main interesting point. So let me define some of the maybe the computer vision with an ML perspective gives this kind of a view for us, right? What are the interesting problems we are solving in industry using some of you may argue, yes, why you are talking about is new problems, maybe traditional image processing also solving a lot of this. Yes, perfectly fine. So it's more like old wine in new bottle, right? So the problems are not new in all the cases, but the way of approach, right? Maybe traditionally we have some kind of image processing, traditional image processing, then digital image processing, those techniques exist. But with the advent of a lot of these digital data these days, just see some of you definitely maybe senior to me, you who have seen the analog cameras, or maybe how used to use the films and all. Now what happened to all the technology, right? So now even cameras, unless you are very much drive by the quality of it, right? Even your mobile phone, most of, or your students mobile phone is more than enough, right, for capturing photos and keeping those memories, and even to the printing that, right? Maybe a large canvas may require large canvas print may require some kind of professional photography or DSLR. But otherwise, what data we are adding, digital data, is through all, talk about all the Facebook, Instagram, all that, right? So how much of data we are really generating it, right? How much of processing it is happening. It may not be just only on the traditional processing kind of thing. Last 10 years is a huge amount of maybe when I'm talking about that, I may have some history before going there. Let me give even a perspective of uh, I can what I can give you here is, if you know the image net, just type the image net, you will see this ImageNet. Actually the changed the way last maybe how many, yeah, 2021 it is. Maybe the latest update is that time they are talking about, that's okay. But overall what we are talking here is this kind of a challenge, right? What it shows is, right now, can you see here how many images it has? It has 14 million images. Okay, or in our Indian terminology, if you see that, I think is it 1.1 crore 41 lakhs 97,000. Yeah, you see that 14 million, it is 1.4 crore images are there. Okay, you can download available. Those images are actually annotated images. Okay, so what does that mean is you have a label for that. So mainly for the classification problems, this actually changed the way the computer vision applications are coming, because it's one of the largest open source data set, and people built a lot of architecture. So when I say CNN, convolutional neural networks, how many people really understand convolutional neural networks? Any response? Do you understand basic convolutional neural networks?
Yes, sir.
Yes, no?
Yes, sir.
Yeah, it's part of data segmentation methods. Yes, correct. At least the basics. I'm not asking the full deep dive. Okay. Yeah, it's a data segmentation kind of a thing, but it can exist as, it's kind of a deep learning method. Okay, or let me ask this way. You know at least basics of machine learning, and now you heard of deep learning. What is the difference between machine learning and deep learning? Any one line answer, if you, I'm not asking big theories and all that, just one line answer. If your student is asking you what is difference between a machine learning and deep learning, in just one line. Okay, I'm getting some answers. You can unmute and tell, or you can chat. Prediction with flexibility DL. Okay. Any other simple fundamental point only I'm asking. Yeah, it's a subclass. Perfect. Uh, Deep learning is a subclass of or subset of machine learning. Perfect.
Good
Yeah,
morning,
I
sir.
think
If
yes.
the data could be labeled, we can mention it as it comes under training the data with machine learning. If the data
Uh-huh.
is unable to unlearn unsupervised, can we put it in deep learning, sir?
No, no,
Sorry.
that's not the right way to put it.
Okay.
But I appreciate your approach, right? But I'll demystify what is wrong in that. But when I'm asking questions, don't curse me, right? So I want to just test how much you are understanding. There's nothing wrong. I completely appreciate whoever given the response. Don't feel whether it's right or wrong. We are all here to learn something. I can learn from something from you. At the same time, I can reciprocate by sharing my knowledge. So don't hesitate to say that it is right, wrong, and all. Don't assume all that. Just give what is there in your thought, and then I can clarify and rectify that. So I can see some more responses here. Features need extract before classification. Yeah, I think some answer from Bharati is close. Okay. Then features raw data. Okay, I'm getting, yeah, even Muhammad also given some information. Deep learning as like architectures. That's more like what deep learning contains. Maybe it is human brain inspired architectures and all, right? So good. Thanks for your response. So let me put this way. So as we say, deep learning is a subset of this is a very important point. That's why even telling you and even just writing as well, so that it will register in your mind, is a subset of ML. Okay, machine learning. That means machine learning has a lot of this, just like you are telling, supervised, unsupervised, reinforcement, whatever you have the subfields in ML, the same subfields you have even in the DL. Okay, but if you see what is the main difference is, just like I think Bharati is mentioning, in case of ML, it has feature extraction, okay, and model development. Both of them are part of ML. Okay. Whereas in case of a I'm using these terms. DL is deep learning, machine learning is ML. Okay. So ML involves both feature extraction and model development. Whereas DL, by pushing a lot of data, I'm not explicitly doing any feature extraction by myself. In DL, we are expecting the model, whatever you are talking on the architecture, it needs to take care of that kind of feature extraction and model development. So here we talk about, in case of ML, we are talking about manual feature extraction. Maybe use your traditional techniques and use your feature engineering. That is another separate field as such, right? Those are all the things which we are doing in ML. Whereas in the DL, we are expecting we are not doing fundamentally the feature extraction by ourselves, but the data, if you have huge amount of data, DL can automatically take care of feature extraction and model development, right? So hope that clarifies. And the same way, the suppose reinforcement learning, you have deep reinforcement learning. Supervised learning, you have supervised learning, mostly classification regression, the same techniques you have in deep learning as well. And another aspect I'm trying to bring there is most of the problems what we are solving in the real world, even in the computer vision, maybe close to 90% of the time, it is supervised at this stage. So that's where what I'm talking now, also supervised mostly. Okay, and I will touch upon these unsupervised kind of aspects when I come to the synthetic image generation kind of a thing. Okay, even if you ask me 90% of my time, also I'm going there, and I'll just give you what advances are going on the unsupervised and reinforcement learning. Okay, cool. So in between, just these kind of interactions will help me to keep you awake. At the same time, what I'm talking is making sense to all of you. Okay, so if you're convinced with that, and some of you understand CNN is a convolutional neural network, is a part of deep learning methodology, specially designed for image handling images. But don't get in an illusion. Some people may get that because, yeah, CNN are always used with images. No, we used even that CNN convolutional neural networks even with the time series data of a regular what I can say, the different regular data means the numerical data. That brings to me another interesting question to ask. When you are learning all these aspects of machine learning and deep learning, right? What are the one way we are learning these methods. Somebody is talking about deep learning architectures. We are learning different supervised, unsupervised, all that. When you are learning these kind of techniques, in real world, we are playing with different types of data. Right? One type of data we are already talking on images. That's where the computer vision is focused. But what are the other types of data comes to your mind? Types of data. There is a lot of ways of telling, because some people may say continuous data, discrete data, maybe structured data, unstructured data at abstract level. But I want to go a little more deeper and say some 5, 6 different types of data. One, I am already giving you a hint. Images is one type. What else? Image can be data, yes, but what are the other types of data which you and me, anybody in industry or research, anybody, we are going to play with this type of data. We need to understand what is the type of data. Then only we can really apply the models. Yes, images is one. Then what else? MRI, CT. Yeah, there are, even in the image data, you are talking about types of image, maybe something on the MRI, CT, but that is not a different types. I'm asking at the scale, at the range of images only. Let's say images, and even computer vision talks about images and videos. I already given clue. What are the other? Yeah, audio data. Perfect. Another, audio means speech. Yes. Text. Perfect. What else? Still two more or three more are there. Basic thing. What you see, a lot of data. Where, what kind of data you're getting from sensors when you're doing the financial transaction? What kind of data is that? Other than video, images, audio. Very good. Numerical. Yeah, you're almost there. So I'll just add the remaining 2, 3 as well. Yeah, streaming data, it can be streaming data, streaming continuous, that can be one type, but it's more of a numerical data or categorical. So what do you mean by categorical? Means some, let's say the medical image, or let's say COVID-19 test, positive, negative. It's not like numerical number, like a BP 120, 80 and all, but it's kind of a yes, no, or let's say sex, male, female, or color, red, green, blue and all, right? So these are the categorical, not text, not numerical. And the last one is signals, right? So these are the type of data which, this is my way of looking at, and hope you are also agree that. Then let me just talk about that, why that is important, right? So if I go back to, just like I mentioned, ImageNet, okay, where is this? Yeah. So if you see here in one of my recent blog, not very recent, maybe almost an year now. So during the COVID, I tried to give what problems to solve with data science during the COVID-19 thing, right? So there, if you see, I am trying to talk about different problems we can solve, right? So, but out of that, maybe if you are expert in text, natural language processing, or if your research is going on, maybe you can look into that kind of problems. Now I am talking about image and video. Maybe somebody, let's say my brother is a professor in speech processing, so they are completely concentrate on the speech level things. Sometimes they are not completely different methodologies, but it depends on how, what kind of background you have and what kind of latest advances you can follow on the image and video, right? So this blog I usually refer. So now, because we are talking on the computer vision problem, so maybe, yeah, on the image and video data, what problems to solve, and then what are the data also. So the interesting point in this blog is I'm talking about 40 different problems along with the data. I can talk about 100 problems. That is good. This is good. But then next question you ask me is what data I can have, right? Another interesting point when you are talking about AI based kind of a thing is we need to have an interesting research problem slash business problem. If I'm talking to the faculty, I use the term research problem. And in the traditional research, if you have a solid problem, that's good enough, right? You can talk about how do you formulate, mathematically prove it, and you can write your thesis, all that. But now, if it is an AI based thing, whether it's a computer vision or NLP or anything, now I'm talking on the computer vision backdrop, there also you require relevant data, huge data of maybe thousands of samples, right? At least you will get some of the samples I given it here. That's one of the aspect which I will refer you. I'm not going to each and everything here, but I have interesting problems anyway to cover. Okay, so this blog link is publicly available. So I even included here as well. Is there any question? I'm getting some noise. Okay. So are you able to follow so far? Is it making sense what we are talking? Yes, no? Cool. So then now I'm going to the backdrop of that, and then now I am actually given you, yes, we know what type of data we are playing with. Yes, we are playing with one subset of data, images and videos type of it. And now what are the interesting problems which we are going to formulate irrespective of the industry? Then I will extend further to the interesting application. The first key takeaway now is this slide where in the computer vision, what kind of problems we are talking about. So one is classification. If you see balloons kind of a thing, or I can give a example of the real world as well. This is just for your representation. Let me give the COVID-19 example. If I have a chest x-ray of because the mostly it is affecting the lungs, right? So if I say if I take the lungs image like this here, if I'm just classifying that particular image as COVID-19 positive or negative, that's a classification problem. If I extend further the same problem, I'm not just satisfied by saying whether it is a COVID-19 positive or a negative image, just like you are identifying balloon here. We want actually the object detection point of it. It is actually, we are trying to tell there are 7 balloons in this image at these locations, and there are the these are the bounding boxes for that. That's what the object detection is saying. So in that particular image, let's say in the COVID-19 backdrop example, even if you are saying, let's say COVID-19 positive, that particular X-ray image, you should be able to give a bounding box. What portion of the particular image is making a decision that it is COVID-19 positive, right? So the one is, what is that? Second thing is, where is that as well? Okay. And semantic segmentation is a kind of an extension to that. That is also kind of where, but only difference there is not just satisfied by saying, okay, die bounding box. It's more like a pixel level classification. So in an image, like if you're talking about this as a X-ray image, in that X-ray image, maybe you are talking about exact portion. Those many pixels are contributing to say some features which are corresponding to COVID-19 positive. That much level we want to go as a pixel by pixel. So if you see the movies these days, the movie title and there is a punchline for it, right? Tagline. Just like that, if you see semantic segmentation, the tagline is pixel level classification, right? If you remember those things, it is easy for you when you are really going into the real implementation. That's called semantic segmentation. That means we are trying to give some meaningful thing, just like balloon, we are trying to identify it here. The same way instance segmentation means same as semantic segmentation, but it has little more in terms of maybe some boundary boxes also there. That's not important, but more important thing is it has a different color balloons, whereas here everything is maybe one color. That means if you have maybe some kind of a textures which are classifying it's a COVID-19 positive, if it is there two places, I want to differentiate in two different maybe two things as a two different instances. That's where I want to give two different colors, just like I am giving each and every balloon as a different color. So as part of the complexity, if you see, classification is there everywhere, but it's just a classification is one problem, whereas this is pixel level classification is semantic segmentation, and object detection is a classification. That means what is that plus where is that? That location, what people call it as localization, classification plus localization. Then instance segmentation is actually a, I'll say in simple words or a more informal words, it's a BOP of all problems. What does that mean? Is it is doing, if you do, somebody does the instance segmentation, I can do the segmentation as well. I am doing classification as well. I am doing the object detection as well. Then interesting question to ask is, let it be whatever the problem you have. Why can't I formulate instance segmentation only and solve each and every problem? Why should I bother about all the individual problem formulations? Because I am saying this is problem, this is solving all the other three problems as well. Then in that case, is it not easy to formulate each and every computer vision problem as a segmentation problem and solve it? But why people are still not following that approach? And based on the type of the problem we are trying to form, yes, I worked on all these problems. Someplace it is good enough for to have a classification problem. Sometimes I need to go at a semantic level. Why we need to think in that way, even in your research problems when you are doing? So why I need to understand all the four things, what it is doing, and formulate that way when one of them is actually solving all of them, all the type of problems. Let me see how much of critical thinking you will bring on the table. Any responses? You understand all four by this time, at least what is that and why is that? I'm trying to emphasize why part now after describing what those problems are. Okay, when you understand, so the critical question I'm asking is why, as a researcher, we don't attempt to formulate the problems, all problems as instance segmentation, because it is solving all the other problems as well. What could be the reasons that people are not attempting to formulate all the computer vision problems in the instance segmentation only? You mean you don't require to be an expert to answer this? We can't locate instances without locating which family of images it falls. Yeah, to some extent, yes. That means the clue is, yeah, to drill down. Perfect. So there is already, I appreciate the thought process. Yes, I'll complement that with some more explanation. Let me just wait for a minute or maybe another 30 seconds just for other people to digest and share. Any further responses? Yeah, data. Perfect. I appreciate Savita Nandan. Yeah, because when you are talking about, I already given you hints. That is like a more complex problem, instance segmentation. Naturally, you can also see that because we are doing more activity, that means it requires more data, it requires more memory. Always we are in the world of engineering where our day-to-day job is to optimize, right? To optimize the real development, deployment, all that. So even though there is a provision to solve all of them, we need to see what is the best way of formulation. That's what most of our research focused on, right? Perfect. So I appreciate your answer. So to come back on to answer my point as well, because it's a supervised problem, that means in classification thing, just like ImageNet has 1.4 core images, that is not having instance level segmentation for each of image. It has only classification. What that image it will tell, it is balloon, it is laptop, it is chair, it is mouse, like that. So if you just see how much of pain point to get the annotations. If I have 1.4 crore images, I have only classification. Now I want for all of them semantic segmentation. Is it a simple one? Somebody need to draw the contours. Contours means, yes, this is the area of a balloon. Then only computer will understand. Now, similarly for instance segmentation, somebody need to draw in a different color, draw a bounding box. See how much of effort it requires in the input data. If you have input data of inputs instance segmentation, then perfectly fine. I can solve the problem on that, right? So these are the maybe the engineering way of talking different problems, and then I'll bring real applications now in terms of keeping the backdrop of different industries, so that you really understand. Yes, now you talk, I just defined what are the different problems, right? Now I'm trying to go deep dive and see what are the real problem. One problem I already talked about, like COVID-19 positive, negative kind of a thing, right? So if you see, that's the first problem in the healthcare. X-ray images, you can have chest classification or even lung segmentation. Segmentation means something like this, right? So where even if you give a lung kind of a thing, maybe I can take an example again here. Is the next slide though? Maybe I will go here. So there is another blog. If somebody is interested in the medical imaging thing, which is one of the core active research area there, maybe this can be of helpful thing. New tab. Okay, so here I'm talking about various types of healthcare data to build top 10 applications, but just like the same style of the 7 types of data, but I'm not going each and everything, but especially the image and video I'm going. Let's say if I go to the image and video, somewhere here, yeah. In case of image normalization, classification, segmentation, these are the things which I explained so far. In image and video, you can have these problems, right? So then what are the different techniques you use? We will go with that. I'm not going too deep into how you are solving, because some of you may be familiar with, some of you are yet to, as you are learning, but I'll give you a backdrop of what the convolutional neural network and all at the later. But otherwise also with the information what we are sharing so far, you should be, and other sessions also, whatever you are getting into CNN or other machine learning techniques, deep learning techniques, you should be able to follow the real solutioning aspects. Okay. So after that, I talked about 10 different like medical imaging, faster diagnosis, like the 10 different interesting problems I talked about, right? So let me cover some of them here. So, and then remaining thing, you can get it from that reference. So if you see here, so one is on the application and what kind of, one is on what, if you see the style of what I'm presenting here in the next one, you need, yeah, maybe industry is just to give you a backdrop where you are applying. More importantly, what data we are using. Yes, what input data I require. Then what is the application I am talking about, and what kind of computer vision technique we are suggesting. That's not the only way to do it, but this is what the one of the technique. Even if you go deep dive into the CNN, as some of you are talking about architectures, what does that architecture contains, right? The one terminology what I can say, the wide adoption of computer vision, especially on the deep learning, is coming from transfer learning. What does that mean is, transfer learning means some architecture, let's say the same ImageNet, as you see here, right here, why I'm referring that ImageNet and then asking you to spend few minutes later on the homepage and what that problem is. That ImageNet challenge has a huge amount of data, and they have a challenge, ImageNet challenge, where last 10 years, many people, best of the brains in the world, have developed to have solving that particular challenge. Okay. And that particular thing, if you see here, these are every year we are getting that ImageNet large scale visual recognition challenge. So every year when you see that, let's say 2013, if I give that, so every year there are winners. Okay, in this particular year, let's say there are VGGNet. So all the maybe Pascal, you can go into the details later, but more interestingly, if you follow this, it will give you a glimpse of so many architectures who are the winners that time. So many fancy terminology like VGGNet, InceptionNet, then RetinaNet, MobileNet. There are so many terminology. I don't want to throw those names, but there are so many architectures where people try to solve this large scale problem. And then we interestingly adopted in the other healthcare problems. Let's say I worked in healthcare before my present role in telecom organization now. So while I'm doing healthcare thing, while we are solving, let's say this classification problem of chest X-ray, that time it's not for COVID, maybe for the TB or other ailments, right? So when we are doing the classification, we not started from scratch. We have taken the architecture. What does the architecture in a deep learning contains? Okay, so I can ask you and you can reply, but in the interest of time, I'm just giving you the answer. The architecture contains the model. The model means what neurons are connected in to the next layers, and the weights. That is more important for us. So that's also common question people ask, what the deep learning architecture contains, right? Even in, when I say transfer learning, I'm taking the reference architecture along with the weights. If you give only architecture, that is not solving the all purpose. Again, I need to build from random weights and learn the weights. That's the crucial part of deep learning, right? So now, if I see the next level of the problems with, let's say, CT, MRI, ultrasound and all, you can talk about again here also brain tumor classification. What is the difference between here? This is an image level thing, whereas the next one is a video thing. But there's same problems also there, classification. Only thing is, instead of 2D convolution, maybe I can talk about 3D convolution. That's the one difference. I'm assuming, yes, these are covered in depth for you in other sessions. That's why I'm just using those terms here. So another way of looking at is at video. Even if you take a frame by frame for a video, maybe you can have, let's say 200 frames making a video. Each frame is an image. Maybe you can do frame by frame analysis and combine that as well. But these days you have even a wrapper classes, or maybe 3D version of it, as some of you are saying, it can do internally like this, maybe doing internally frame by frame and analyzing, but it can give you one analysis from the 3D video itself. Right. There also we can classify, then do a semantic segmentation. And another interesting point, why it is important for us in the computer vision is for two reasons. One is you need to, let's say take the COVID example, right? Most of you are coming from different parts of India, and now we are talking about again cases are increasing. There, if you see the chest X-ray kind of, there may be basic test of swab test and all, but if you, even if that is not the, if in the elementary test is not satisfied, then people are going for the lung chest X-ray kind of a thing, right? So there, even let's say if I have 1,000 chest X-ray images, how many of them may be positive, COVID positive? Maybe 10, maybe 100. So, but 90% of the data is still one class, which is, let's say, negative class, right? So that the problem is called class imbalance. You may argue that that's the actual reality in the in the actual reality, but why you are trying to perturb the distribution of the data if you are talking more mathematically. But the problem is, yes, maybe there is inherent bias, to avoid inherent bias towards the negative class, right? So that's the reason that people call it about synthetic image generation. This is one of the interesting application. I'm just talking on the healthcare, but it can be universally applicable. I have one slide to explain in deep as well. To do that, along with the statistic techniques, the latest technique what people are using is generative adversarial networks. This itself is a separate field, but if you are not comfortable even understanding what it and all, if time permits, I'll talk, but otherwise just note down that's an interesting field of research, how GANs can be used. Maybe it is 4 years old by now, but it is doing a lot of wonders, right? And especially one application of that is synthetic image generation. Then in case of automobile, autonomous driving, yes, I have one more slide for this to explain it further on, and that has object detection, semantic segmentation, these kind of interesting techniques. One beautiful application is autonomous driving. Okay, so some of the research is very old. I still remember maybe 10 years ago when I visited Google campus in US, they have a small track, and they have the small vehicle talking about doing the routes and all that in that particular track in the research environment. Then we wonder as a researcher at that time, when does it really come to reality in any near future? But within 7-8 years, we are talking now the on the roads of US or some other countries as well. At least now approvals and all government it is technically or maybe scientists have already proved, yes, we are building the safe and autonomous driving systems, right? Even a lot of Indian startups are also there which are focusing on that. The primarily, this is not just only computer vision, but the primary application of that, somebody is asking GPS related information, one of the faculty. So even they are all using a lot of GPS data in this, and then they are coupling with object detection and semantic segmentation. There are interesting algorithms on that. I do have next slide. That's why I'm mentioning to you. The references there will be very much helpful. Let's say you may argue that I'm not using that into the automobile case. That perfectly fine. But the research in that, whether you are trying to use it for your agriculture or some other application, but you can cross leverage those architectures. That's the beauty of that, especially on the deep learning perspective. So next application is a telecom, where I am working these days, is one new application. People not thought of it in a couple of years ago. See, the towers, what you are seeing, you and me are in the for the mobile connectivity, right? You see the towers and the cells are situated there. How we are taking care of the quality in that? So does it mean that somebody, this site engineer or network engineer is going climbing those towers every time and then doing it? Not really possible, right? So if to give an example, a place like Mumbai may have 1 lakh towers for each operator, like Vodafone, like Airtel, like Jio. So that's much scalable problem here. So maybe how do people know that? Usually, let's say some kind of complaints people are coming up, maybe some issue are there. Okay, let me fix it. Okay. But the new way of computer vision way of doing it is what we are not talking some science fiction here. These are the things which are we deployed in some of the countries as we speak now, not in India though yet. But what does that mean is we are tied up with some kind of a drone image organizations or companies, maybe small startups kind. They go and capture the drone images or videos of a particular towers in a particular area, and they will charge for that. And once they give the data to the cloud environment, and we take that into the computer vision application, identify object detection, visual inspection of items. Okay, is there any exposed parts? Is there too much of bending of the cable? Like the 30 different applications we are developing. Now we are in the initial phase of maybe some 2-3 real deployments, and then in future we are talking about tens of those applications across the world. So these are the new applications with the advent of computer vision thing. At the same time, other like Internet of Things or the drones, the other technology is also boosting the real applications like this. Okay, or the same way, I can give a more realistic application where you most of you can relate. These days, if I ask you where the people are using the drones, maybe in agriculture to some extent, some research, but more interestingly, the marriage functions, right, or movies. So they can see that what can, and let me ask this way, these drones, can they become intelligent running some kind of a deep learning model in the drone itself? What could be your response if you are following me? The same applications, is it really possible to have intelligent drones which can be running some kind of a deep learning methods? Yes. Okay, possible. Yes, a simple application I'll give you, maybe to make it more okay. Sometimes I may be thinking more technical oriented, but I can give you a real applications for you. Let's say the marriage functions, each have most of you coming from different parts of India, right? So let's say the drone is and there is somebody controlling the drone, right? So physically controlling it, just like your remote control car type of it. Yeah. And what is this anti drone, Savitanandan? Okay, while you are explaining that, so the simple application I'm giving, so where to focus? That means if it is trained on, let's say, 100 marriage ceremonies in Andhra Pradesh, or maybe 100 marriage ceremonies in Uttar Pradesh, right? So maybe of a typical community kind of a thing, then it really understand the sequence of events, which part to focus automatically, because they are trying to, maybe some event is a thing which they need to zoom in, zoom out. Yes, there is a creativity from the individual, but if it is trained on these things, it can also supplement and give it to you and take a real-time decisions, which portion to focus on, which one to highlight, which one, when to zoom in, when to zoom out, these kind of things. It's a simple way of explaining the things for you, where you and me can relate to, right? In the entertainment domain, that's also interesting. I think $1 million business there as well, right? So but the same way we can talk about these applications. Then if I go further in that, yeah, in the retail, so Amazon Go checkout, so there also object detection we are talking about. Previously also it's more of an object detection. I'm not going into deep dive into object detection in single shot, two shot kind of a thing, that anyway you will be complemented in the regular course. What are the different ways of object detection? So at this stage I'm trying to give you or excite you with the applications, so that based on your interest you can deep dive either in classification or in segmentation or detection. Okay, so Amazon Go is kind of a automatic checkout. With the advent of this COVID, what we saw this, we want to minimize the human intervention, right? If you go to a shop, what Amazon Go talks about is there won't be anybody in the shop. We just go, don't even require to pay. Okay, we just recognize you by face. Maybe you go there and pick whatever you want, and then we'll charge your wallet. So how good to see that way, right? And then how much of security requirements it has, so that the people will not spoof the system. And then how accurately they need to, they have, it's mainly because of computer vision and IoT. So both the things, they are taking place. And if you see the retail, human pose estimation or human pose generation, it's similar to what you have seen computer vision application. You may be recollecting recent maybe images of WhatsApp, how you look like when you are 60, or when you are 20, how you are there, right? So there are talking about a lot of image generation, that's with the GANs, right? Then traffic identification. and security purpose, that also has object detection, instance segmentation. See the real example in the social engineering, if these webcams or maybe the cameras, okay, these integrated cameras, right, the CCTVs cameras. So if you see that those cameras are continuously feeding the data. Suppose if somebody is violating the traffic signals, and then and there if can I alert, okay. Or some interesting application previously during the COVID thing, what they have done is these days development of these applications is not taking a couple of months, right? Few days is good enough because a lot of technology development advancement happened. But to make it to industry grade, maybe a couple of weeks it requires. I'm not oversimplifying that. Say one example, recent one is, let's say that time Hyderabad police trying to see during the lockdown period, you are not supposed to cross, let's say 5 kilometers from your radius. But how do you validate those? So they install some kind of the software in the traffic signals, and they're able to capture these different cars which crossed maybe 2 signals, 3 signals, and going to different zone, and able to generate the fines on the fly, right? So that way we can customize these kind of applications once we have the basic models on top of the regular classification detection kind of a thing. Then face detection and offices and airports. Okay, if you the nowadays now, maybe we want to limit ourselves, maybe the fingerprinting. Okay, maybe most of your colleges have that one. Now let's say if they want to implement a new system, because I don't want to have the touch, right? So there is some kind of a Siamese network is one way to look at to detect your face. Maybe all authorized persons, faculty, students have given some pictures. Okay, we are not asking tens and hundreds of pictures, maybe 2 3 pictures is good enough, right? And then use these networks to really identify whether you are the person, right? So just like face detection in your mobile, we are talking about face detection in airports, and it is really feasible these days. Even I remember a year ago, even in the Bangalore airport kind of a thing, they just started doing it. In some of the airports they want to make it, you don't require to carry maybe your other physical or digital documents. Maybe your face can act as a uh, identification for yourself. Okay. Then finding a person in the crowd is just like take the example of Kumbh Mela or Makkah Masjid, the trip, right? Makkah trip. So people talk about, these are real examples where millions of people come together. There are people using technologies of these drones, videos to track the people, and from the security point of it, or even on the social angle, to find the who is going and where, and then is there any suspicious activity, or even the kids, are they safe, or do we need to alert? So along with the traditional patrolling or policing, these technologies are really helping the people to maybe not to cause the damage, at the same time from the security aspect as well. Then from the media point of it, image captioning, style transfer, I already mentioned. Generative adversarial network image captioning means if I give an image, maybe the automatically it can generate the caption for that, or maybe a description of that. In case of banking, fraud detection with signature. Okay, so there are a lot of interesting signet kind of a thing. Okay, then agriculture, image from drones. How do you estimate the crop yield? Can you take pictures from these and then identify? Let's say these days people are talking about organic thing. Okay, there are huge amount of startups are available. A lot of research is going on. How do you ensure that is really it is organic? Okay, are you monitoring continuously? Okay, even if you put a continuous CCTV, or maybe log everything in the blockchain to where from the seeds are coming and all. Okay, how do you ensure again a suspicious activity? Somebody putting how much of dosage of the particular pesticides, right? So that was interesting problem to estimate and then really verify from the image perspective, computer vision perspective. Right? So those are the high level applications for the first 1 hour for me. And let me take a pause. Any questions before we deep dive into the next portion of it? Okay, are we good so far?
Yes, sir.
Okay, if it is making sense, then we'll shift the gears to the little more deeper applications. Okay. Okay, anti-drone jammers that can detect unauthorized drone and nullify. Yeah, that's a good security related application. Yeah. Okay, so if I go to the next one into the applications of image processing or medical imaging, right? So if you see here, because there are a lot of applications, I just talked about only one, two there because it's an interesting one. I thought I will say here one application, specific applications. Each of them can be a thesis level kind of a problem, right? So mammographic mask classification. Here, what does that mean is we are trying to get in mammogram is more like your breast cancer. So there to identify that at a different levels. When we worked with this kind of a problem maybe 3 years ago, we have an interesting startup that time where instead of the traditional identifying mammogram costs maybe let's say 5,000, 6,000 kind of a thing, and a lot of Indian people may not be able to maybe go for a proactive checking every year. Maybe people government advisors or maybe the WHO advises the ladies who is above 45 years age, they need to check at a regular interval to see this kind of whether they are prone to this kind of a cancer. But for an Indian kind of ecosystem, we need some more, maybe more affordable different techniques. That's where one startup, Niramai, you can search more details in the internet. They talked about thermal imaging based AI supported thing, which is maybe with a few hundreds of rupees. Okay. And that too, they are these days getting a lot of CSR initiatives from that. They're going to villages and doing a proactive, this mammogram kind of, not exactly mammogram, but maybe let's say this breast cancer detection in it through thermal imaging. That's a different way of doing it. But ultimately, their aim is whether they are going it a mammographic route or maybe the thermal imaging route, they are trying to classify that. A lot of computer vision role is there. Then second thing is segmentation of lesions in the brain. Okay, so in the brain, as the color coding indicates, we are not just talking about the classification, just like a previous example, but we are talking about this one of the complex surgeries. So if you see that, right? So the neurosurgeons are one of the highest paid surgeons in the world, and that too brain surgery. I remember seeing some videos from some doctors, right? So it is more like a almost like our the concentration or maybe the level of accuracy what they need to go is like a our hair thin level. So if they cut something other than that, maybe it can impact something else in the brain, right? So they should be accurate to that level. So they do a lot of these computer vision, they say even augmented reality kind of a thing, where they will try zoom level and try it and experiment in even before going to the actual surgery. There are a lot of things which can, like this MRI or CT can give us a lot of information about that. They recreate some of the scenarios and see specifically where the issue is, and then apply the techniques to what to segment, right? There are complex cases like that. Then leak detection in airway tree segmentation, you can see how the leak is. On the diabetic retina, you have some open source data set for this, and that means for the this is in the eye. There is a diabetic retinopathy. Can you identify that? Okay, if they are diabetic, and is there any way to identify proactively that they are going to be prone in upcoming days or months, so that you can do some corrective action, right? So another segmentation, prostate segmentation, then nodule classification. That means here, can you identify lung segmentation or nodule classification? These are the interesting points. Again, some breast cancer related metastates, then skin liaison classification here, then bone suppression here. They're interesting. If you're into that field of it, then it makes sense, right? Medical imaging. And this is not my own applications. I talked about some of them mine, but this is the interesting article I have seen, and these are the, if you want more details, you can go there. In all these applications, what interesting another research area for you is a lot of maturity happened in last few years. I started working in from 2017 on this, where yes, we are developing a lot of deep learning, machine learning models, but how do you convince the doctors or even regulators that really it is working? Be it your segmentation of a lesion or be it your chest X-ray, any of those, right? So that the interesting computer vision application there is how do you identify the feature visualization and localization, those aspects, right? So if you go into the specific application of that, Let me tell you this way. One is understanding of, let me take the example of this. If I take about this X-ray, I keep talking about just X-ray and all, maybe this is the image I'm referring it to. One way of identifying the features is at a high level. That means entire feature level. I don't want what each layer is learning. That's a different level. That's mainly for the developers. But for a doctor, okay, or regulator, if it is a X-ray thing, maybe these, some of them you may understand, some of them you may not understand all of them. That's okay. But these are different techniques, right? Like gradient based class activation map or class activation map, silence map. These are existing open source algorithms. Let me put that way. If you use these for not only for chest X-ray, for any of your images, you will get these kind of images. Okay, what does it mean is, once you classify that particular image to positive or negative for that particular classification or particular class, you can get, okay, this is class 1 because of this particular features. Maybe this is more prominent and followed by these, or using silency map, or maybe the color coding like this. What does indicate is, maybe if the doctor sees it, he may not understand in and out of the deep learning or machine learning model inside, but he can really see what portion of the image is getting focused. So when we work with the doctors on particular this case, what they say is, yes, it can happen 4 cases. One, yes, the image is classified correctly and the portion is also perfectly fine. This is the portion, because of that, even as a human, I will also classify that. That's the best case. Worst case is, yes, it is not classified as image, and anyway, you are not giving me any image portion of that why it is not classified. That is also okay. But the other 2 cases is, yes, you classified it correctly, but this is not the portion. Maybe this is the portion which needs to be highlighted. That means I need to give that feedback, again retrain. Whereas other thing, it's not classified as a positive COVID, but it is identifying the features, but your classification is doing something wrong, right? In each and every case, we analyze based on the data and then we retrain it, so that we can, at the end, we are trying to improve the accuracy. Not just only accuracy, it may be sensitivity, specificity, whatever you are comfortable with your machine learning feature, maybe the evaluation, right? That is what I'm not going to deep dive into the specific methods though. But if you are interested, just Google it, you will get what the technique is. And you don't require to code it. You will get the, along with the code, you will get the implementation, right? So next thing is, as you see, that's called actually discrimination or grad cam kind of a thing. That means at an overall image level, I am talking about. Whereas other approaches of feature visualization means, I need to improve the system now. Okay, I'm not doing the correct classification. I need to improve. That means, how, just like in your convolutional neural network, you have at each level some kind of an activation map. What does it mean is, you have pixels, and pixels are mapped to, let's say, the features. Somewhere it may be, yeah, visualize the activation of a feature map. That means the features are available and you are trying to map the pixels to the features. Whereas deconvolution is a reverse process. That means you are reconstructing the input image. That means you are you are mapping back the features to the pixels. Okay, maybe one is a forward method, other one is a backward method. Ultimately, the purpose is to identify how many of dead filters. You may understand what do I mean by filters, right? You may have some high pass filters, low pass filters, Kalman filter. That's a traditional way of getting the filters. In convolution, the weights itself are called filters. Let's say you have a lot of parameters and hyperparameters in convolution neural network. Then if you want to increase or decrease, you should have some basis, right? These kind of convolution, deconvolution, or activation map can give us some clue what kind of features it is learning, what kind of features it is struggling to learn, so that you can tune the parameters accordingly, or maybe add relevant data effectively to build a better generalized solution. So these are latest techniques where we are talking about not taking granted the particular machine learning or deep learning model development, but we want to deep dive and enter into the black box and understand how things are happening, for main purpose of, one is to improve the performance, second thing is to convince the doctors and regulators so that we'll get the approval and wide adoption. One more step further, as I mentioned. So maybe I'll talk about, yeah, this one, right? So I told previously there are GANs. Maybe some of you may argue, myself very new to GANs, and now Sunil, you are talking about different types of GAN. Okay, just even if you're already familiar, then I'm adding some more deep dive. If you're not familiar, just remember there are some kind of a research on generative adversarial network. Somebody is talking in a FDP level. If you get a deep dive, that's perfectly fine. But otherwise, you understand the purpose of that. Whenever you have that kind of a class imbalance, or you want to generate some new images or new data for that matter, not just only images, then you can think of these GANs and maybe deep dive a little bit that time along with the traditional techniques, right? In before maybe these GANs main usage on synthetic image generation, people used to have oversampling techniques, something like SMOT, if you heard of synthetic minority oversampling, those kind of techniques people used to have that. Okay, I'll talk about that example. But what is GANs also at a simple level, let me tell you, and then I'll go to, talk about that example for you. What is GANs is as it has two things, generative adversarial networks. So if some of you are seeing what we talk mostly machine learning now is a kind of a discriminative model. What does that mean? I have some data, I want to discriminate whether it is a classified like this, whether it is a detected like this and all. But there are some generative models as well. Okay, something like naive Bayes, okay, some kind of a probabilistic models. They are generative models as well. Here, as the GAN's name indicate, there are two networks actually. One is a generator network, other one is a discriminator network. So these are what I can tell you in a simple words is more like a thief and police. Okay, or for somebody, let's say, trying to get a fake notes. Let's say this is a gentleman who is a thief and he want to produce as close as possible the fake note so that the discriminator who is a police find it difficult to discriminate that. So that means there are two, both of them are going hand in hand, and we need to reach to a equilibrium that the generator able to produce the quality of these fake notes, which is difficult for the discriminator, the policeman, to distinguish. That is the equilibrium state which they need to get it into. But what happens, how does that really work is if you have a some local variable, random variable, and using a generator and generating a sample, initially that is just like a noise, right? But if you get some learning from real world images, like this note, real world images means, let's say this 10 rupee note, 20 rupee, whatever the note, 500 rupees note. When we give the sample, the discriminator, initially it is easy for it. Oh, yes, it can easily identify by comparing the results here. Yes, generator, whatever generated is a fake note. But there is a loss function which is helping to learn from both the aspects, what features it is developing here, what features it has there. So over the time, generator is becoming powerful and giving as close images as possible so that the discriminator is getting it, finding it difficult, right? So the people can argue, people can misuse these GANs, right? Yes, that's other way to look at into. This is one example, but there are positive ways of applying that as well. That's where I'm giving example of, okay, conditional GAN, auxiliary GAN. There are 100 types of GANs. Don't worry at this stage. But what I mean by that, some abbreviations, what you have, you ignore that. But some type of GAN, let's say, exists. What I have images showing it to you is a cervical cancer images, which I played maybe 2 years ago to play with. I have limited set of images only, but can I, by using those images, can I conditionally, that means if you see the synthetic image generation, I'm not trying to generate for generic images. I have one minority class which has only, let's say, 100 images, whereas other majority class has, I think, if I remember, 2000 images, maybe 1900 belongs to one class, and then maybe 100 belongs to another class. I'll take those 100 and then try to understand the distribution like this and generate those cervical, in this case, this cervical cancer image, but it can be any images, but I just presented to you what I have worked on, right? So if you see here, initially the images may be looking like a little blurred and all that, but if you see, these are the quality, maybe low resolution, but still they are quality images you are getting, okay? So that means how many minimum images I need to do that? Can I do it with 100 images? Do I really require, maybe it's kind of a chicken and egg problem. I need some minimum images to understand the distribution and reproduce it. But if I have enough images, maybe I don't require to reproduce, right? That's why it's not like a completely solved problem, but interesting way to look it into is at what resolution. People talk about super resolution. Even if you give an image of 64 by 64, maybe if you want to have a 640 slash 640, now there are already super resolution algorithms which can enhance without losing the quality. Okay, so a lot of development happened in the computer vision that way, which not only discriminative level but even at a generative level as well. These just some examples from uh, my reference, what I worked on in that journey. If you take the next level, autonomous driving example, okay, I talked about touched upon this research and all that, right? If I take these images, okay, there are a lot of camera information. There are the CNN, convolutional neural networks. They have information from radar information, GPS signals. They're all combining together to make a decision. Yes, is the speed okay? Can I speed based on the speed limit? Can I go a little more faster? Or do I need to apply brake? Am I seeing any signals? How I am following the next, just like the typical driving action. If you are in a driver's seat in your car, each and every second you need to take a decision, right? Whether it's a ABC, accelerator, clutch, then a brake. So the same decisions even this system needs to do. And if you see the complexity of that, per second they are giving the camera of this much. The radar information is this. Okay, GPS information, as some of you are asking, this much of GPS information is available. Maybe Tesla may not be using LiDAR or other information. This is more like different sensing data. Doesn't mean that all of them using all of them, depending. Some of you are using only GPS, camera, and radar. Some of them even using the sonar and LiDAR. Okay, they're different sensor data. Okay, but if you want to see, I want to present to you how complex they are in terms of data handling, right? So how that related to the computer vision aspect of it. If you see here, let's say if this is a image which is autonomous car, from the lens of that, this area will look like this in a segmentation, semantic segmentation. That means it needs to identify what are the pathways for it, valid pathways following the signals, right? So only this, I maybe pour it the, maybe this is whether it's violet or magenta, whatever the color you call. So the road, whatever is the classified as road, is the only way. It can't touch the car, it can't touch the buildings, it can't touch any other class, right? It will be violation. So these kind of semantic segmentation, somebody is asking in terms of even if they're linking this with the GPS as well, there are interesting models, something like UNet. Okay, semantic segmentation, if you're really doing, there are some architectures like UNet architecture, right? You can just Google it, you will get it. And those are the things which you can use not only for autonomous driving, anywhere you want to club this, let's say GPS data along with the camera data, those are the things which people can really use it. So before going to the challenges, one more simple example. Okay, you may argue, Sunil, you are talking about much more bigger problems where hundreds of researchers are using all this one, but we are small groups in our colleges. So can we talk about some simple examples as well? Yes. So if you see that, a simple example, I'm talking about rust identification, maybe on the pipeline, maybe on your vehicles, okay, maybe your college water tankers or any of those, right? So if you see that, what kind of architectures we need to do that? Okay, some of them are real identification, some of them can be a predicted model, right? So if you want to identify and give a class, okay, when you need to really replace this, is it already crossing the threshold? Okay, so you are really talking about the level of object detection, and you can use some architecture of VGG or maybe some YOLO SSD. There are a lot of aspects. If time permits, I'll give you the specific algorithm level as well, but at least at this level, I want to share it to you. Even this can be problems like this, which may not be very big. At the same time, you need to collect some images, okay, and then annotate those images, okay, in the sense, how do you really identify the rust level? Okay, you may have 0 to 100 scale. You need to have some data which can feed based on this image. Okay, this portion is of this portion is of this. So then we feed it to the architecture of maybe single shot like YOLO SSD or two shot, maybe RCNN type of it, recurrent CNN. or region CNN, not recurrent, sorry. Right, there are now, if you say that there's a lot of technical availability of the models, you don't require to scratch from scratch, but you need to really create the right set of data with the annotations and then have a pipeline. That's why I will talk. Once you understand all these different problems, then different architectures, how do you build really the solutions, and how do you really solve the problems in an applied research fashion? That I'll talk next. That's the last portion from for the talk. But let me take a pause here and see if you want me to deep dive in anything what I talked so far in terms of the applications. Can you explain GAN? Yes, Rupa, I have done a little bit, but let me, I done little bit of GAN explanation. So are you getting that, Rupa, or shall I go further? Yeah, you got it, right? Yeah, and that's an interesting thing. For if you are really interested in GAN, the reference what I can give you there is there is a GAN Jew. Okay. But don't get frightened what kind of how many different GANs are there. Okay, so see, total number of papers, it's just coming from 2016. Now it is almost like these many papers per month. Okay, it's coming in the recent past. Okay, so there are so many GANs. Okay, just search by your interesting thing and then you'll go into that. Okay, I don't require to go through all of them, but it has a good reference. I'll just type it in the chat as well. Okay, so Bharati, which type of GAN for medical image? As I mentioned to you here in the GAN, what worked really for me is a cyclic GAN, and depending on there also, it's not like complete medical images only that one type of GAN, but what worked really for is like this auxiliary class GAN and conditional GAN. Those two are these two things. Okay, auxiliary AC GAN and classifier GAN. Those are the things which worked for us. When do you prefer ANN, RNN, CNN application specific? Very good question, Rupa. So the artificial neural network is a deep learning. Is there any difference between deep learning and ANN? You ask me a question, but I'm asking one more basic question back to you. So is there any difference between deep learning and are the people using interchangeably? Not so much. Okay. So almost same, but only I will say usage difference. Artificial neural network means it has a what is a neuron and all that. Okay, DL is part of ANN. Yes, I'll agree, but it's more like to explain that part. I used to take the help of. I'm not going deep dive there, but TensorFlow Playground. These are interesting tools to. Where is that? Playground.TensorFlow. This just play some time here. I'll just give you a glimpse to answer your point here, but it's an interesting thing even for you to follow. Oh, why these many? Don't worry all that. Just have a bookmark this, that will be helpful for you. Why I'm taking that? This will help you to just play with. This itself take maybe half an hour to explain. I'm not going deep dive, but if you play with, let's say if you have only input and output and only 2-3 neurons. Okay, I just play with this. You are classifying that with some data set like this. So this is actually artificial neural network based thing, but this is not a deep learning. The deep means people say that at least you should have maybe at least 2 hidden layers, one input, one output, you leave it in between. At least you need greater than 2 hidden layers, then it is called deep learning. That's where the deep thing coming up. But some problems are there where without even with one layer itself you can solve. Yes, that's perfectly fine. But the real world problem, let's say take this. Maybe first ignore this. Maybe if you are talking about this, you can't really converge the complex problems. If I want to separate this yellow to blue kind of a thing, it will be difficult with maybe one layer network kind of a thing. If you have a deep learning, then it can really solve it much more better way. So like that, it is good for you as a simple UI based thing, even for the students to play with. This I usually give it in the deep learning kind of a sessions, but because you are asking the between RNN and all that, I thought, okay, the first difference is all deep learning methods are based on ANN, but there are existing ANN methodologies which may not be deep learning method. Even with one neuron, I can solve. For instance, here to solve this, just to clear separation problems, I just need one neuron. That's it. I'm able to separate, classify it. Correct? It is not a deep learning method. It's a simple neural network method. Okay. But if you want to have a complex problem and all, we need more than 2 layers. That's where the okay. This one actually the what you say the specifically DN and N. I am talking about only one part now. I still not answered completely the Rupa's question. So in the present ANN, where the complex problems to solve beyond, let's say, 2 layers or deep layers, when you have, that's a deep learning, basic deep learning, or people call it as feed forward networks. You might have heard the same term, right? FFN, feed forward networks. That's what I've shown you so far. That's the basic deep learning. Then CNN will come into picture mainly for images or two-dimensional data. Two-dimensional data. That means where the two-dimensional data is coming here, mainly from pixels. Pixels or have width, height, and all that. And even for 3D also you can use it. Okay, so whenever you have this kind of images or a space, or maybe the general term I use, whenever there is a spatial correlation of the data, whereas RNN, recurrent networks, okay, there people, you can use the recurrent network whenever you have a temporal correlation of the data. That means the order matters for you. For instance, in case of image, if the order is not matter, then CNN is good enough. But if you see a sequential events, right, where there is an order in a chartbot, you need a sequence of event. If you want to predict some next state of, let's say, how many cases tomorrow we can expect in India, that means I need to analyze last 1 month or 1 year data. Okay, if that is the case, then you need to go into a level where the temporal correlation or the maybe the order matters. Then you need to think of something on the RNN. Okay, does it clarify? ANN, yeah. And don't think that these are independently there. Suppose if I have a video, I need to have a recurrent network, I need to have a CNN. That means you can combine RNN plus CNN as well. Or image captioning, you are talking about the CNN plus the regular network. So you can combine that. But this is the basic understanding for you. Thank you. So any other, can you please share few detailed algorithm with road marking for intelligent vehicles? Any specific algorithms in simple, sir, if time permits? Okay, road marking. What do you mean by road marking? That means identifying the signals, is it? Okay, yeah. So I can tell you right away. So for those identifying path, there are interesting things. The model YOLO SSD. You just type in Google that maybe YOLO version 4, the present one. Okay, they are doing good actually, right? V4, and you will get the code as well. These are called single shot object detection models. Okay, so you maybe covered some information in the other sessions, but otherwise also you just Google it, you will get it. How GAN can be used to image fusion? Okay, Image fusion, can you elaborate what you mean by image fusion, Bharti? It can be used for image generation while collecting the features from other images. Features mixing of NRI. Ah, okay, got it. Image fusion means you are talking MRI and CT image. Okay, people will you get a different sources, right? You have different purpose. MRI, soft tissues and all will be very much visible there, and then compared to CT, it has its own purpose. Okay, the technology is completely different for both of them, right? Okay, that's from the background. When you have images fusion, what does that mean is the GANs you need to, there are step by process like this. First, you need to understand, I'll give you one example, not exactly image fusion, but you can understand how you can do that. So we need to identify the motion detection in MRI. What does that mean is sometimes, let's say the patients are more anxious while they are into the bore, that MRI bore, right? So if they move, the instructors or technician will tell, please don't move, otherwise you need to rescan or you need to come again and schedule all that, right? But due to some anxiety and all, people will knowingly or unknowingly move. And what we've done there is, okay, that's not mixing MRI and CT, but I'm talking about one particular modality. Let's say MRI. The motion detection is an interesting application because once we have the image reconstruction back to that, once it is less than or once it is greater than a threshold, the motion level, then we do the rescan only that particular portion. And then we get that particular image and then we fuse it in. That means, what does that mean is the missing pieces we can add GAN to add the delta, but ultimately I have a scan 1 and I have scan 2. I am trying to replace some of the scan 1 where there is a motion part of it with this, and if there is any gap in between, I am trying to supplement with the GANs. So that is one example of image motion detection and fusion thing which we have done. Okay. Maybe in your case, you were also thoughtful because MRI is giving you some parameters, CT is giving you for the same parameters, maybe the same portion of the body. If you want to fuse it, then there are some physical properties, not like just superimpose one to the other. Maybe you need to do some kind of a segmentation, right? Some portion, okay, maybe these kind of bones are very much visible in CT. If you overimpose that with the other softer tissues, maybe ultimately it is giving combined view of it. You may need to eliminate a lot of other details so that you can really concentrate or segment your own related portion. Yeah, I got your point, what you are saying. So the techniques for that is segmentation first on what information you need to extract it out from individual image of CT and MRI. First, I'm talking at a frame level because those are videos. First, try to do it at an image level as a sample example. Then try to, and another interesting point is you need to have the same type of dimension. Okay, same type of proportion, same set of settings. Otherwise, even one is of 200 cross 200, other one is 200 cross 100. You can't directly superimpose, right? So the basic techniques of image processing or image pre-processing you need to take care. After that, the role of GAN will be to fill the gaps. If at all you see there is a gap, then only you need to think of those. Otherwise, it's a simple traditional way of combining two images. If you see the gap, then the GAN can play the role. Does it make sense? Okay. Source for data sets, radar, geosatellite data, and helps with autonomous driving. Okay, very good question, Rupa. I thought I gave somewhere else. No. Okay. So there is something like papers with code.com. Okay. Recently, last month only, they given it. In the Kaggle, you will get the GPS related information. Maybe have I not given papers, PAPERS with code? Yeah. So papers with code.com, they have hundreds of papers which have the code implementation as well. The main interesting point is the data sets here. Okay. So maybe if you are talking about driving, Let me search if you have. Okay, can you see here? Honda Research Institute driving set, Davis driving data set, Indian driving data sets. You have some and self-driving cars related data set. Okay, so another beautiful aspect is, can you see that? Based on the filter also you can do image, video, audio. You remember the type of data we have, that kind of thing also you can have that. So this also I am pinging you guys, and I already included in the this as well. This is one of the good data set. Maybe instead of direct, I need to put it to everyone. Okay. Very good. So, and another thing, maybe if you see specific application which is of your interest, maybe you can, I given a lot of, based on somebody of you are asking on the images. So there's a lot of data on the Kaggle and the GitHub thing on a specific thing. So usually the image, this is one good resource which the people compiled around 3,200 as of today, right? And Kaggle is one another source. And then Google also has a Google code search, that not code, the data set search, right? But this is very good example for you people to start with, which is very latest. How to find mRNA data set of the same organ? Please share. Um, uh, what is that FBK link? I didn't get. Is it this link you are talking about? That link I already mentioned. Sunil Kumar Sharma. What link you are asking? Okay, so CT and MRI of the same organ means, okay, asks about session organizers will do. Okay, no problem. Okay, so what I'm asking now, so if I have last 40 minutes, so then I have another 10 more minutes to talk about some of the challenges, and let me wind up officially and come back to the questions. So hope I already answered most of the open questions to you. Only thing I have, one thing is, find the MRI and CT data set for same organ. Means easiest thing if you are asking for the same organ is, there are some data MRI and chest X-ray images, I know, but for the same organs means, let me search here itself. Is it there? MRI reconstruction is there, prostate MRI segmentation data is there, but the same organ is a good question. So then there are, if suppose you are not getting for the same organ, maybe you need to create a data set, or maybe tie up with one research hospital. That is one way for your research to start with. Another way to look at is, because the problem is, unless it is coming from same source, it will be difficult for you to recreate. Maybe you get an MRI data set, but of a particular geography, particular data set. If you want to recreate again for the your CT, it will be difficult. Just for such for the same, maybe medical university providing both of them, then that's the best option. If that is not finding, then you need to recreate by yourself. Okay, fine. So let me just officially cover the rest of them. Yeah, LinkedIn. I already mentioned LinkedIn thing. You can easily find out me by just typing. I'm active in this first one itself is this. Okay, so I'll just ping this as well. We can connect. Not an issue. So then let me cover more interestingly the last few slides, which summarizes some of the things, as the title indicates, application of machine learning kind of a thing. So yes, I talked about some high level applications, different verticals, then specific 3-4 different examples. Now if you want to prepare one of them, or maybe if you want to apply computer vision thing in your own model, these are the 4 steps. Okay, you may say it's very standard process, Sunil, what you are bringing on the table. Yes, you have input data. You start with a business problem or research problem, then input data, pre-processing, feature extraction, and ML model, and maybe the evaluation and deployment will follow. But if I take an example like this, in the input data here is images and videos, then don't jump directly to building the model. That's where the people, and believe me, in the industry, if you see that entire portion of, even this is not the complete cycle, I'll say this is only 50%, then model evaluation, then model deployment, and then retraining as coming back. So it goes in iterative fashion. That's where the data science life cycle, we call it as. If you see in the entire life cycle, model development is hardly 10 to 15% of the time, even if you may disagree, hardly 20%, let's say. Rest of the time, our 80% goes into remaining activities. Okay, even though the data scientist is the fancy term, it's not like 100% of the time we are just doing the model building aspects. Okay, the same way, the research point of view also, don't think that okay, I'm not spending much time on the model building. No, don't worry on the first, you will get it. But the main importantly, getting the data ready, doing that standardization, doing the transformations, normalizations, exploratory data analysis, a lot of data, maybe a lot of tools are available in the maybe open source community, even when you are using Python, or the maybe the what you say, a lot of graph level tools, exploratory tools. Okay, EDA we call it as exploratory data analysis. You please need to spend time on that and identify the distributions of the data. Okay, then the feature extraction. You may argue, I am using not a deep learning, I'm using a deep learning model. Can the feature extraction can take care of that? Yeah, it can take care, but then at what cost? The deep learning model is demanding more images. If you more images per class you need to give, then it can have luxury of, yes, it can divide. Otherwise, in the real world, maybe you need to supplement. Okay, it's not like either AML or DL. I may need to do a hybrid as well. First, I use some kind of an ML, maybe extract some features, and then maybe generate more meaningful images. In this particular case, I'm talking images. Then collectively, I'm giving it to a standard architecture in a transfer learning method and solving it and observing the maybe the performance and how to tune further, maybe output layer or input layer, adding more features. So effectively, when you are getting a final model which you are improving on top of the some results in the literature, what does that mean is you have done something differently. That's where you need to highlight in your papers why you are able to get. Maybe you are playing something with the data and something with the model. It need not be always a model. Okay, one layer I added, then it done a magic. No, okay, that also can have, but the people will want to go a little more details. What is so special about that? Have you done something innovatively there? Okay, or you played with okay, the same data. Sometimes you are avoiding some noise. Sometimes you are adding some noise to make it generalization, right? So you go step by step on that. That's where the building pipeline kind of terminology is very important. And finally, then build the model and then go for the evaluation. Other design constraints, we call it as here. So nowadays, I talked about interesting applications on drone. Computer vision is not just only limited to the cloud. Okay, but how do you really go into that? Okay, so how do you decide whether I need to go with the edge, whether I need to go with the cloud, whether I need to go with the hybrid, right? So just think of it. Your end, actually, there's a big framework like something like plaster plus set framework I talk about, but I don't want to complicate that. But I just given it in the reference. So if at all you want to go further deep dive, but at least the basic considerations for you is, if you want to give her some real-time edge processing, as some of you are asking, maybe autonomous driving or some kind of drone level, some processing. Some of you are talking about anti-drone and stuff, right? So if you need to make some immediate decision making with the small set of data, then you may need to have some edge processing, some intelligence on the edge as well. Whereas you need to have embedded and accelerator. That means you need to develop a model. At the same time, you need to extract that particular model. So if you see the latest developments, what they're happening in the edge AI, the terminology is edge AI there. What does that mean is, you are not developing entire model on the edge. That means you are taking the model from edge, developing in the server, maybe GPUs, cloud and all. Once you have the final model, you are trying to tune it to the hardware, small scale hardware, which is there in the edge. To do that, all this NVIDIA, Intel has a lot of software and hardware, which is available in the market in the last few years, where you can optimize, not just only software optimization, friends here. It's more of hardware plus software is giving you the best optimizer results, right? That's the another interesting research area. That's where I'm talking about embedded and the accelerator. And sometimes people can argue we are using only for the inference point of it, the edge level. Okay, to make a decision making. Maybe your mobile can act as an edge. You don't require it. May taking some input, giving back to the cloud for maybe processing or training, but you are talking about inference here. The same way in the cloud processing, what you need to do that it is mainly for training, where you have huge data of terabytes of data to process, where you need to have a server based and maybe accelerated thing. Again, here also you can do some optimization both from NVIDIA GPUs or Intel CPUs kind of a thing. But ultimately the design consideration demands what kind of network to choose in the beginning itself. I usually give this example where if you know the final development model you need to put it into a drone or in your mobile, you don't want to start some complex architecture. You need to think from the beginning itself or some kind of a mobile net. Okay, you have choice of picking up some standard architecture in the beginning itself, but to save the time you can start with mobile net app kind of architecture, right? And then the subsequently what kind of optimization you can take. Those are the design considerations. If you are interested in this kind of an aspect, then I'll give one reference here where maybe one, yeah. So the maybe the last year I was talking about this. So these different challenges I'm talking about here on the drift, and this talks about something like okay. So this talks about something on the, if you are interested in the plaster plus, I'm not complicating it, but if you're interested in the design considerations further, you will understand what that is plaster and set some kind of a trade-offs. Okay. So can you clarify edge from clouds? Rupa, I'm trying to answer that hopefully, right? You are able to get that point, or do I need to further clarify? Okay, clear, fine. So almost we come to the last points and then I'll give you a few more minutes to ask. So I have one more, two more slides. Okay. So we talked about what design considerations we need to talk about, and then to overcome that, right? So just like you were asking, I can see that some of you are already working on where some kind of medical imaging like MRI and CT, or some of you are asking on the GPS related ones. If I not answered any of your open questions, I'll talk in the last 10 minutes though. But to summarize those points, the research may be coming from the quality. If your data is not quality, if you are not getting the quality data with the quality, then you are difficult to get build a sophisticated models. Okay, and there are regulatory issues. That means people talking about GDPR. GDPR is the European thing, and even we do, I think, have privacy rules even in India now. So we need to get the approvals. In especially, let's say, take the example of COVID vaccines, right? So that's not computer vision, but just to give you an example, unless some country approves, you can't go to the real deployment, right? Similarly, even these models, when AI is taking center stage and then trying to classify that, making a decision thing, that means it requires an approval, FDA approvals or regulatory approvals. So increased accuracy and robustness, it may cost. So why that, what does that mean is, it is easy for us to implement some kind of, let's say Amazon checkout, some issue happened. What will be the problem? Maybe some couple of dollars loss for the organization, maybe some security issue, they will correct it. But if some decision is done wrongly, it may cost a life in case of healthcare or even autonomous cars. So that's why they are subject to a lot of regulatory environment. Handling data explosion, that means efficient infrastructure and model should be there, and which one to run where, edge versus cloud. And some places you need stream, one is development, but you need to do a real-time processing, say stream processing, like with the Spark and all that for the real-time applications, right? You might have seen recent privacy. It's like a most soft after, but we don't really worry much. But if you see recently, let's say the WhatsApp privacy thing, how much of importance people are talking about, and then with one message, maybe the Signal or other Telegram might have got a lot of momentum, right? So these are all backed up by simple things like this, simple policy issues. Some of the things like Google, we are giving a lot of consent without our knowledge. Some people jokingly say that Google understands more than our spouse in home, because we are spending more time on mobiles and we are giving a lot of information, and they understand, Google understands mostly our tastes and all, right? So the latest advance is what Dr. Devi Shetty, if you know, he's an Narayan Hridayalaya Padma Bhushan kind of gentleman, highly respected in the medical community. He says second opinion by software for diagnosis will be a trend in next few, he says 10 years, but maybe 2 years ago, maybe another 5 years or so, or 5+ years. What does that mean is, now we go to multiple hospitals, but now one doctor and even extra opinion, I want to take it from the system. If I give this data, what maybe final decision is not that, it takes some time, but we are going to believe slowly the systems, right? So that's where we are going in terms of next steps. But as I'm talking on the next steps, I just talk about one of the global forum like Thinkers C60. When I given the predictions last year, I mean end of last year, I was giving predictions to 2021 and beyond. I'll just give that remark towards the end and leave for further questions. So what my prediction says, this is not related to the computer vision only, but in general AI or data science. So I predict AI will be pervasive in the next few years. What does that mean is, being academicians like you, or maybe industry people, or your students who are going to the industry, this becoming a mainstream, having the titles like data scientist, data engineer, and all using AI in most of the enterprises. Then more emphasis will be building. So as you speak in 2021, we talk about basic model development is not a challenge, believe me. But the main challenges are just like we are talking about edge AI. Edge, you understand the term edge now, right? The either drone or especially in the computer vision point of it, mobile or drone, those things are trusted AI. How do I believe security? One point I mentioned, it need not be a black box. You need to open up. Yes, that's good. But if you open up too much, it will be prone to the security. That's where the plaster plus set framework, I argue, there's always a trade-off. How much of information to whom I need to give? Maybe for regulator, I need to give more information, but may not be for the other end user that much information, because it's security prone. If you remember the Robo movie, there the blue chip, sorry, green chip and red chip. Maybe our hero developed a green chip, somebody intruded that and made it into red chip, and the blame goes to the gentleman. He need to prove in the law of court that yes, he is not responsible by the time damage already happened. So these are looking like a cinematic kind of a thing, but these are the real world situations going forward once the AI is in the mainstream, right? That's where ethical issues are coming into picture, right? Then unsupervised reinforcement, along with the supervised, what we talked more, the future research may be on the reinforcement, federated, generative adversarial networks kind of a things, which will take momentum. Then organizations may focus on using AI with unstructured dark data. Why I'm using dark data is people collect a lot of data. Even take about your own universities or maybe your own institutes. You take a lot of data from students, their marks, this and all. Are we really analyzing that for the welfare of the student or maybe for the welfare of the institute, right? You are sitting on a lot of pile of data. So can we use it for a specific objective, or maybe partner with respective organizations who are open for that? Okay, then that's what the last thing, for a better decision making, better career choices, better gaining efficiency. Okay, towards the end, COVID-19 pandemic, my personal presumption is it will make more AI more essential across the industries. So with that, I'll just summarize and close and take any further questions. So let me leave my thoughts. We're saying there is a huge potential for computer vision across the industries, and you can take any research problem and work on. I covered some of the examples from healthcare, retail, manufacturing. I even talked about design considerations and what challenges we face in this, and and towards the end, I just covered what are the next steps or predictions from my side. Okay. So I provide a couple of references already with you and some more blogs. And the last reference I leave you with is most active blog, maybe most popular blog from my side, which has maybe already 25,000 views. Is it this one? No, it is not opening. This is not the one. Or you can just type, that's okay. You will get it. Top research problems. I don't know why Google this is. I'm done with from my thing, and let me open up for the questions. Okay, not Gmail. I want google.com. So if you say top research problems in data science and big data, if you want to talk about that, they have a blog on that. So this is my blog on that. Okay, so there I'm talking about 20 research problems. So some of you may connect to based on your background. Some of them are only big data related, core big data related. Some of them are data engineering related. Some of them are security related. Some of them are intersection of big data and data science. So if I can inspire some of you with this, we'll be happy to. Okay, so we are almost last few minutes. So thank you, Rupa, for your nice comments. Anything else? Any last questions which I can? So I already shared my easiest thing for me to connect is LinkedIn. LinkedIn message is as good as I can reply there. And if you want me a mail ID, this is my mail ID. Maybe I can give that to everyone as well. I'm just sharing that. Okay. Sorry. So I shared my mobile and sorry, I shared my email ID and LinkedIn. I am active there. So those should be the best way to contact. So any hope it is making sense, and I hope excited you on the interesting research problems. So the last remark I can make is there are interesting problems in the research. So let's all collectively solve the real world problems for betterment of the society. Yeah, I'm right on time. So let me hand over back to organizers.
So a very special thanks on behalf of Department of ECE. It was really helpful. We academicians will not get to know this much content to do our research, sir. It was really helpful. A big thanks to you, sir. A special thanks from Department of ECE and our HOD, Dr. Ravi, sir, who could not make it now because of his administrative work to speak to you. Thank you
No
very
problem.
much, sir. Even the chat box is filled with excellent session, wonderful
Yeah, I could see
sessions.
that. Thank you.
Thank you very much, sir.
Yeah.
Thank you, Dr.
Okay. Thank you and all the best.
Thank you.
Thank you.
Thank you, sir.
Bye. Bye.
I request all the participants to fill the feedback cum attendance form, which is shared in the chat box for the session. I repeat, I request all the participants to fill the feedback cum attendance form, which is shared in the chat box. And the afternoon session starts at 2 p.m. Thank you all.